Hello, this is Karl from SLS Zone, all things serverless, and this video is on what is serverless, why is it good, and how can I use it. Serverless is essentially a software development architectural approach for things like APIs, web applications, and event-driven processing. The reason why it's called serverless is because instead of managing your own hardware or servers to run these apps on, you only have to write the code and others will configure and host the infrastructure for you. So yes, there are of course servers, you just don't have to concern yourself with them when developing an application. All you have to do is write an upload function, put an API in front of it through AWS API Gateway, for example, and you've got a live, scalable, fault-tolerant API endpoint, which is great. There are four main facilitators for this type of serverless computing. There's AWS Lambda, there's Microsoft Azure Functions, there's Google Cloud Code, and there's IBM OpenWhisk. And they're all quite similar, but they've all got their own nuances and different language support. And so if you want to write an API in Swift, you'll need to use IBM OpenWhisk to host that for you. AWS is probably the most mature platform. Google allows you to perform runtime debugging, which is quite cool. And IBM lets you upload your own containers and essentially use whatever language runtime you want to use, which is quite interesting. I should also mention the serverless framework is different to serverless as a concept. And I'm talking about the concept of serverless computing. And what the serverless framework is that it helps you manage the deployment and development of a serverless stack for these various providers. So I'll have links to all this stuff below so you can read up. There are three main reasons why serverless is good. And the first one I have to mention is scalability. Your functions will scale on demand, per request even, without you having to lift a finger in setup or configuration. This also means that your stack is fault tolerant. You cannot break your infrastructure stack with a bad execution. The provider will just spin up new containers on demand, ready to go. The second I'm going to mention is cost effectiveness. You only pay per use. That means that when your product is under heavy load, or any load really, you will pay per millisecond of compute time. And when it's not being used, you will pay nothing at all. So this model is ideal for MVPs or new product propositions that haven't yet shown you success. Even if your app is under heavy load, the pricing is quite comparable to running your own infrastructure stack and considerably cheaper than running a platform as a service model. The next one I'm going to mention is maintenance and DevOps reduction. As you're not provisioning your own instances of hardware, you no longer need to be concerned with things like firewall security patches and routing logistics to some degree. Developers can focus on writing the application and not configuring the environment. And there becomes a blurred line between DevOps and backend developers, as essentially a backend developer should be able to manage their own serverless stack. So what this means is it's very easy for you to get productionized products up and running live very quickly and ready to take a large amount of traffic if the product does reach success, which is a brilliant model to work with. So why is it bad? And well, it's not bad, it's great. However, there are some applications that are probably not suitable for a serverless architecture. Apps that require low latency are probably not suitable for this design pattern. Things like trading systems, or if you need to do some heavy data processing, like training machine learning models, like that is probably not the right architectural pattern to use for that. But if you're trying to serve, like serving ML models or creating an API for a to-do list or a single page web application, then serverless is brilliant for that type of thing. The other objection that people have is provider lock-in, and that's true to some degree. Lambda functions you write will not directly port to Azure or Google. However, if you're moving cloud providers, there's going to be some lifting and reworking no matter how the product is architected. But there's tools to help you mitigate this in serverless. And so the serverless framework, which lets you define your serverless app structure, can be ported between different cloud providers. And if you develop your functions with something like SLS Press, which is what we use, it'll help you minimize normalize the entry points between the different cloud providers. And so the only other updates you need to look at if migrating from one provider to another are things like the other services you use for things like persistence or messaging. So the cloud providers don't specifically tell us what's under the hood of their serverless functions. But there are some behaviors that we can take from the way they operate, which will tell us something about the way they are structured behind the scenes. And there's a concept of a warm startup and a cold startup. And that means when you call a serverless function, if there's a container ready to serve that request, you get served straight away. But if there's no serverless function available behind the scenes, or no container which has been spun up essentially, it will take some extra latency to spin that container up. And so when you see heavy load, you might see more low latency spin ups or more cold startups as more containers are spun up behind the scenes. It also means that they're reusing containers to some degree, and that reuse means you could persist some element or some entity within the state of that container, which you might be able to reuse for other functions which execute, but that's not generally done because there's no quality assurance around whether that state will be held there, and so you try to keep your functions stateless to some degree. So all serverless apps can be created manually. Like you can upload your own functions separately and create your own API routes and configure your own runtime. However, this can be quite inefficient and erroneous to reproduce and doesn't help you spin up new environments for staging and production. So for this reason, people use a framework called the Serverless framework, and this provides you a configuration interface for infrastructure as code, essentially, in which your app will use this to manage the deployment of your serverless stack to your cloud provider. In AWS, this will create a CloudFormation configuration, which will create your API gateway and deploy your Lambda functions and configure these services for you with all their security principles. So thanks for watching the video. This is Karl from the SLS Zone team. We'll be creating a series of tutorials on serverless computing to help you learn, build and run serverless applications in a production environment. All details and example code is available from the site sls.zone, linked below. Leave comments, questions, suggestions for video tutorials that you'd like to see, and we'll add them to the list. Okay, thank you.